Hello everyone, this is Cyrus from AML and my topic is interactive exploration of 3D scan baggage. First, let's this what is interactive exploration of 3D scan baggage? Let's discuss. An interactive visualization system can support volumetric data exploration in airport security screenings by addressing the challenges unique to the baggage inspection. The proposed system includes a set of interactive techniques that combines the direct manipulation of voxels and their interactive visualization. The system final tools and GUI graphic use design incorporate feedback from airport personals and were validated by real world users in terms of effectiveness and ease of use. Existing systems. Before going to the this interactive exploration of 3D scan baggage, what are the existing systems? Let's discuss. X-ray scan is the existing system with the three standard colors: orange, green, and blue. The orange color is used for low density materials. If there is a bag in that contain some materials and different types of materials, the low density materials are indicated by the orange color and the high density materials are indicated by the blue color. The green color correspondent to either this superposition of different kinds of materials or average density materials. Either it may not be low density or it may not be high density. Average of the density materials is represented by the green color in the X-ray scan. Since the resulting X-ray scanned images only contain densities, it cannot display the material original color. For example, there is a bottle color called yellow color. For example, yellow color. But in X-ray scan, we can only represent it by only three colors. That is blue, green, and orange. So we cannot represent the yellow color as it is of the bottle color. So this is the disadvantage of these X-ray scan images. The display 2D images can suffer from these issues. Superposition. A thread or prohibited object like knife cutter may be sheltered behind the dense material. Sometimes it is possible to see through this blind shield using some functionality such as high penetration, enhanced X-ray power, or image processing. Next, location. Depending on its location inside the luggage, a thread can be difficult to detect. Objects located in the corners, in the edges of or inside the luggage frames are very difficult to identify. For example, superposition means if there is a material called high density material, behind that there is a knife or will threaten objects like knife or cutter, we cannot detect that objects. That is the superposition. This is a location means if there is a objects life knife or cutters at the edges of the bag, so it cannot detect properly. This is the and another disadvantage of these 2D scan images. And the disassociation, another way to dissimulate a threat is to separate and to spread part of it in the luggage. Weapons or explosives are composed of many separated items like the trigger and the cannon. This association can be combined with the other dissimulation techniques. For example, a gun, this trigger is separated and body is separated and some parts are separated, so we cannot detect it properly. It is a harmful weapon. So this disassociation is also not possible in this extra scan. And lure, an ill-intentioned individual may use a lure to hide the real threat. For instance, a minor threat like a small scissors may be clearly visible and the catch security agent attention, while a more important threat remains hidden. interact. What is, so we have discussed the existing system, that is XRS 2D scan images. Now the interactive exploration of the 3D scan baggages. 3D baggages can scan explorations are one potential solution of such limitations. Till now we have discussed the limitations of the two scan disassociation and lure and the location and superposition. So we can overcome these limitations. Few systems investigated these activity domains with interactive volumetric exploration tools. Even if extensive works have been done in medical 3D scan exploration and manipulation, there is a great opportunity to adapt and develop new interactive and data manipulation techniques to support 3D baggage exploration. This performs following operation: get the data. To get the data in the bag, so we'll perform this operation: visualization. User need to visualize the content of the luggage. Next, exploration. User has to explore the baggage with interactive navigation system. Next, occultation. The system must provide tools to address occultation issues. The superposition of item inside the luggage hidden there, visualization. Next, user need to explore luggage with simple interaction. User knowledge is too limited regarding volumetric data processing to understand the involved techniques and their parameters. Top level structure. Our system is composed of one main view. This, whatever we are discussing, interactive exploration of 3D scan, this contains the one main view, that is volume visualization, and 5 subviews to control the customize item, customize it. Here we can see, here we can see the volume visualization and the next other 5 views: view options, toolbox, transfer functions, and overview, snapshot, temporal instance. Our interactive system does not provide menu and very features is directly accessible from this main view. The volume visualization can contain up to 2 views to ease interaction with the 3D scan. The view displays the baggage and one can navigate through its zoom, pan, rotation, manipulates its content, brushing, selection, deletion. So these views contain the zoom. We can zoom the bag and pan and rotation. Brushing means and erasing something. Selection and selection the object, and deletion means deleting the one object to see another object behind that. These two views can be linked or disconnected in order to inspect selected objects with or without their content. A smaller view called overview shows the location of the investigated area. The overview is 1/8 the size of the main window and is located at its bottom right. Bottom right. Overview is located at the bottom right. Object selection and investigation. Selection of an object. We developed 3 different ways to select objects. The different modalities, that is we can use by hands or mouse or pen. After the target is selected, our system tries to find a better point of view to display the selected object with the minimum of occluded parts. Occultation management. In order to address occultation issues, the eraser tool can interactively remove selected objects from one view to the another one. To restore a deleted object from one view, the user has to erase it from the other view. This simple principle guarantees that every item of the luggage is always visible while addressing occultation issues. Here we can see the transfer function represents their continuous interaction. The highly density materials are revealed by dragging from left to right on the present. Here we can see the rotation option. We can see here we can see the rotation option, so that we can see the side view or top view or bottom view, anything top view. By using this rotation option, we can use this inspection of an object from different perspective. The user defines an object of interest for further inspection. The object is then inside box with red borders. The user modifies the transfer function to see the target in another content. The user rotates the baggage to look at the means for a different perspective, it stay visible whatever the manipulation carried out. In this activation of 2D view, 2D view, here the object is selected and the activation of 2D view. We can see the selected object here. Selected object is here. If we want to see the particular object, so we can use the selection object. Next is deletion of the bar. For example, this is the abstract, this is the bag, and this is the bars. So if we want to see the object behind these bars, so we can easily delete these bars by using the deletion object option. Here the brushing is erasing the objects. If you, this is the bag, the, if we scan this, the bag is showing like this. If we want to see what are the objects inside in this, so brushing is applied so that we can see the object which are there inside the bag. Brushing plus rotation. Brushing, as we have discussed, brushing is removing objects, brushing and erasing that. And rotation means we can rotate to see the objects in the other angle. So interactive exploration of 3D scan package is a innovative interaction to support baggage exploration. By using these tools, we can easily get the data of an object which are present in our bag. The main advantages of this tool is to scan the bag in 3D view, and also it has the special features like object selection, brushing, deletion, zooming, and rotation. These features help to explore the objects inside a bag. Thank you. This is all about the interactive exploration of the 3D bag scan.